Okay, assalamu alaikum my dear brothers and sisters, welcome back. Today on board we are going to discuss about area of quadrilaterals in Form 2 concept of mathematics. In this video we will solve problems related to trapezium, parallelogram, kite, you see. Those are what we are going to see by the way. Then guys, make sure you go with me step by step. We'll also see rhombus for reading. Then we will start with the area of parallelogram under this area of parallelogram. And remember, a student is expected to know what are the properties of a parallelogram. Okay, a student must be instilled of having the knowledge of what a parallelogram is. So a parallelogram is a figure whose opposite sides are equal and parallel. Okay, it has two diagonals. The two diagonals are not equal. The two diagonals are not perpendicular to each other, meaning they are not bisecting at right angle. Yeah, just understand that. Opposite angles are equal. Opposite angles of a parallelogram are equal. Okay, base angles of parallelogram are also supplementary, meaning they add up to 180 degrees. These properties are very, very important when it comes to construction of parallelogram, and to some extent when we are actually dealing with the application questions based on parallelogram. Okay, now let's see an example from this one. Let's see our first example. Example 1, we are told ABCD is a parallelogram of sides 5 centimeter and 10 centimeter. Okay, 5 centimeter and 10 centimeter. Full stop. You're told, look at this point. Let's see this here. You're told if angle ABC is equal to 70 degree, comma, you're told find the area of the parallelogram. You're told find the area of the parallelogram. Parallelogram. So this is the figure. You must know how to do this thing. Line should be straight. Okay, you have this one. Let's say this is the parallelogram. Okay, these are parallelogram, so these two sides are parallel. This is 10 centimeter. This will also be 10 centimeter. Okay, this one is parallel to this one, and the side here is 5 centimeter. This angle is 70 degrees. So this is A, B, C, and D. Okay, having this information now, we need to get the area of this kind of parallelogram. Remember, we said in primary that area of parallelogram is equal to base times height. Okay, where our height used to be this one, okay, or this one. Now we don't have this height. But when you come to secondary, remember area of parallelogram is gotten as base times height sine theta. Okay, base times height is gotten as base times height sine theta. Why are we saying that? Because assume now this is our height. We don't have the height, but generally we know that area is equal to base times height. But when you come to secondary, there will be slight change. Okay, look at this one. I will express a height. How can I get height? I will say using this angle and the hypotenuse given. Look at this triangle. This is a right angle triangle. Yeah, just understand. So I'll say opposite of hypotenuse using this angle. So I'll say sine 70 degrees is equal to opposite all over hypotenuse. So we can still say, come to this point. You can say sine 70 degrees is equal to opposite what? H all over the hypotenuse, which is 5. We are looking for the value of h, remember. So we can say times 5 here. Cancel these two. So we'll have height is equal to 5 sine 70. But we know that area is equal to base times height. So we can say our base is what? 10 centimeter times 5 sine 70. Okay? That will give us what? 50 sine 70. So that will give us 49 foot 6 point. Area therefore is equal to 46.98 centimeter square. 98 centimeter square. Okay? That will be your area. Just understand. We are saying you will express the height first. We know that using this angle and the hypotenuse, you can say so. We can use what? So. Remember, we always use SOHCAHTOA where it's possible. SOHCAHTOA. So we are going to use sine because we are looking for the opposite, the height, and we have the hypotenuse. So we are going to say sine 70 degrees is equal to opposite, which is our height, divided by the hypotenuse, which is 5. Then from there you're going to get what? H, which is the height. So you eliminate this one by multiplying both sides to get the value of h times 5 times 5. H therefore is equal to 5 times sine 70. But basically we know that area of parallelogram is gotten as what? Base times height. So this will be your base. The line which is perpendicular to the height is your base, remember. So we are going to say area is equal to base times height, BH, which is our base is 10 times the height, which is 5 sine 70. For your information, guys. So that's how we are going to calculate the area of a parallelogram given the height and what you normally call the angle. Yeah, just understand that, guys. Then in our next class, in our next concept, we are going to discuss about area of trapezium. Okay, area of trapezium. Let me write it here. Area of trapezium. I know this reflection of light, so let me write here. So this is how we are going to calculate area of a parallelogram. So come to this point, let's write area of a trapezium. Remember, a trapezium is also learned in primary. It's also there in primary when you're learning area of figures. We know that back in primary we say the area of trapezium is equal to a half into a plus b times h, where a is the longer side of the trapezium, b is the shorter side of the trapezium, and height is the h of the, and h is the height of the trapezium. Just understand that. Now, without wasting time, let's go and see this one. Let's go and see our first example. This is our first example. You're told, example 1. You're told the figure below is a trapezium. The figure below is a trapezium in which BS is parallel to QR, comma, BS is equal to 15 centimeter, BS is equal to 15 centimeter, comma, QR is equal to 20 centimeter, QR is equal to 20 centimeter, comma, RS is equal to 8 centimeter, RS is equal to 8 centimeter, and angle QRS is equal to 35 degree full stop. You are told calculate the area of the trapezium. Calculate the area of the trapezium. Now this is the figure. This is our figure, remember? This is our trapezium. So this is 15 centimeter. This is what? 15 centimeter. Just understand that. Centimeter. So these two sides are parallel. This is 15 centimeter. This is 20 centimeter. We have B, Q, R, S. Here we have 8 centimeter. As they said, this angle is 35 degree. Now when you look at this figure now, when you look at this figure, you can also say this is also 8 centimeter, okay? And this angle is also what? This angle is 35, don't forget that. So now the question here is, we know that area, let's come to this point here for solution. Let's come to this space here. Let's come to this space. Take your time. Okay? We know that area, let's write the formula. Area is equal to a half into A plus P times H. Now, we know that this is the height of the trapezium. That will be the height. So let me write the H. And remember, this angle is what? 35. Don't forget that angle is 35. So I have to get what? H. So I will still say sine. I'll say sine 35. Sine 35 degrees is equal to opposite, so all over the hypotenuse. Okay? Now let's call this point M. Okay? Then we can still say, for you to understand, you can say MS all over hypotenuse, which is SI, okay? Which is equal to H out of 8. So we can say sine 35 degrees is equal to H out of 8, okay? Then we multiply here 8, we also multiply here 8 to get H. So H of which you're going to use will be 8 times sine 30. Or you can say 8 sine 30. Simple. You can say 8 sine 35, okay? 8 sine 35. So now area therefore is equal to a half into the longer side 20 plus 15 times 8 sine of what? Sine of 35 degree, okay? Look at that. So you're going to say what? It will be by 2, 1, by 2, 4. So area is equal to this, add this 2. That's that 5. That 5 times 4, 140. Add this 2, that 5 times 4, 140. Sine of what? Sine of 35. So if you are a great mathematician, you can use log. Okay? I will solve using log. Or you can say this times this. It will give you the area. Okay? Look at that. You can say this will be how much? We are going to say 140. Look at this one. 140 sine 35. That's 80.3. 80.30 centimeter square. Alternatively, what you can do is you can use the log, the table here. You can use logarithm of what? And logarithm of cosine and sine to get the value of this one, okay? In a table manner. Just understand that. You can also get that. Then that's how you're going to get the area of a trapezium in high school, okay? You will get first the height. You will create what you normally call an expression showing what the height. So when you get the height is when you can actually get the area. And remember we say the area of trapezium is equal to a half into A plus B times H. But in this situation you don't have the true height. So what you're going to do is using this angle and the hypotenuse, you're going to say sine 35 is equal to opposite, which is H all over the hypotenuse. From there you formulate H here, how to get H. Then H is equal to 8 times what? Sine 35. That is the H you're going to take for the calculation of area of the trapezium for your information, guys, okay? We will proceed ahead and see what you normally call area of kite, okay? Area of kite. I hope you are getting this thing. It's very easy. Just understand. Okay? Area of kite is what you are going to see. Area of kite. Okay, let me wrap this thing. Area of kite. Area of kite. Okay? But before I go into that, let me also give you example 2. Okay? So that you understand better this thing, yeah? Let me give you example 2 about area of trapezium, yeah? Let's say this is example 2. Example 2. So you're told, calculate the area of the figure below. Calculate the area of the figure below. Calculate the area of the figure below. So we have this thing. We have this figure. This is 9 centimeter. This is 14 centimeter. This is 150 degree. And this is 5 centimeter. Now when you look at this one now, when you look at this figure now, basically what you know is the moment they're saying this line is straight, remember? Okay, this is 90 degree. This also 90 degree. And we know that the sum of interior angles of a trapezium adds up to 360 degree. So what we're going to do is, when we want to calculate, we need to get this angle. Okay? We are going to say 360 minus the summation of these three. So let's call this angle as x here. Can you take x? Yes. Let's say x plus 90 degree plus another 90 degree, which is this one, plus 150 degree is equal to 360 degree. Just understand that, 360 degree, because the summation of the interior angles will give us 300, because these are quadrilateral. Just understand that. So it will be x plus 180 plus 150, 330 degree is equal to 360 degree. So x is equal to 360 degree minus 330 degree. So x therefore is equal to that degree. So this angle is what? This angle x is what? Is 30 degree. So we can name this angle as 30 degree. Okay. Then what are we going to do? We are going to drop our height here. Just understand here, height. So right here, h. So let me express that. I will say sine 30 degree is equal to opposite over hypo, which is the hypotenuse, which is equal to h out of 5. Because my opposite is what? That h, and my hypotenuse is 5. So I'll say sine 30 degree is equal to h out of 5. Let me write clear this thing so you understand better. Let me come here. You can say, look here, we can say sine 30 degree is equal to h out of 5. Okay? H out of 5, sorry. H out of 5. Then to get h, multiply both sides by 5. Okay? Cancel this thing. H is equal to what? 5 sine 30 degree. 5 sine 30 degree. Okay, now let's come to this point. We know that area is equal to a half into a plus b times h. So area is equal to a half into a is 14 centimeter plus 9 centimeter times 5 sine 30. 5 sine that. So this will give us what? Okay, this will give us area is equal to a half times, add this to 23 centimeter times let's say 20 here. Okay, 23 times 5 sine of what? Sine of that. We know that by 2 is 11.5. Okay, so area therefore is equal to 11.5 times 5. So it will be 11.5, okay, centimeter times 5 centimeter times sine 30. Sine of what? Sine of that, okay? So area therefore is equal to, use your calculator, 11.5 times 5 times sine 30, okay? So this should give you how much? 28.75 centimeter squared. So that's how you're going to calculate the area of this kind of figure for your information, guys. Yeah, just understand that. That's how you're going to calculate the area of a trapezium. Okay. Then we will move to area of kite. Area. I hope you're getting this thing. You will form an expression for the h, then get the area. Okay. Let's go to area. How to calculate area of a kite. Okay. How to calculate the area of a kite. For your information, guys. Area of a kite. Okay. Area of kite. Let's see that. tall, the figure below represent. So we write area of what? Of a kite. Area of a kite, okay? Then you're told, example 1. Example 1, you're told the figure below represent. The figure below represents a kite. Full stop. Find its area. Find its area, okay? Find its area. So this is the figure. We have, this is the figure. This is the figure. This is the figure. So we have here, they say that this is 5 centimeter. This also 5 centimeter. This angle is 50 degree. Here we also have these two, they are same. So here we have 7 centimeter. Here also 7 centimeter. Then we have here angle of 35. Okay, a kite is made up of two triangles that are not equal when you look at these two. Because if you now join these 2 points, so this will be an isosceles triangle and this will be another isosceles. So I'll call this one A and this one B. So I'll say area of the figure, area of the kite is equal to area of A plus area of B. So let me get area of A. Area of A is equal to half AB sine theta. Because I know I have two sides and include the angle. So I'll say it's equal to half times 25 centimeter squared. 5 times 5, yeah, half AB times sine of what? Sine of 50. So by 2, 1 by 2 is 12.5. So area will be, get the calculator. It will be how much? It will be 12.5 times sine of 50, okay? That is 9.58. 9.58 centimeter squared. Come to this point, then you're going to say again, area of B is equal to half AB sine theta. So area therefore, come to this one, half AB. So you're going to say a half times 49. 49 comes from where? 7 centimeter times 7 centimeter times sine of what? Sine of 35. Just understand that. So this will give me by 2, 1 by 2 is 3.5. So area is equal to 3.5 times sine is what? 24.5 centimeter squared times sine of what? Sine of 35. So 24.5 times sine of 35. So that's 14.05. Area is equal to 14.05 centimeter squared. Now area of the kite now. Add area of the kite will be, add these two, 9.58 centimeter squared plus 14.05 centimeter squared. 14.05 plus 9.58. So that will give us 23.63 centimeter squared. Okay? Just understand. Divide this one into two triangles, then use half AB sine theta for your information to get the area of the kite. Okay? To get the area of the what? Of the kite. In our next video, we are going to see area of, God willing, area of polygons. Okay? So have make sure you subscribe this one and share with your friends and family members. Otherwise, I wish you the best.